The word agent has become overloaded. A chatbot calls a weather API, and someone calls it an agent. A coding assistant edits a file, and someone calls that an agent. A product adds MCP support, and suddenly every integration is described as agentic. But these are not the same thing. There are three layers that people keep mixing up: tool use, MCP, and agents. Tool use is when a model can ask an external capability to do something. MCP is a standard protocol for exposing those capabilities to AI applications. An agent is the orchestration loop that decides what to do, calls tools, observes results, updates state, and keeps going until the task is done. Those layers are related, but they solve different problems. And if you mix them up, you either overbuild simple automation, or you ship something that looks agentic but cannot actually complete a task reliably. Start with tool use. A language model by itself produces tokens. It does not directly read your file system, query your database, send an email, or run a test suite. Tool use changes the interface. Instead of only producing prose, the model can emit a structured request, call this tool, with these arguments. For example, call, search, files, with a pattern and a path. Or call, get, weather, with a city. Or call, edit, file, with a file name, an old string, and a replacement. The important part is that the model is not literally executing the action. The host application is. The runtime receives the model's tool request, validates it against a schema, checks permissions, runs the actual function, and returns the result back to the model as an observation. That result becomes new context. The model can now answer the user, or decide it needs another tool call. This is the basic mechanism behind function calling, code execution, retrieval tools, file editing, browser automation, and a lot of modern AI applications. But a single tool call is not automatically an agent. If the user asks for the weather, the model calls a weather API and then summarizes the response. That is tool use. Useful, but not agentic in the strong sense. One subtle point: the tool interface is itself context. The model sees the tool name, description, argument schema, sometimes examples, and sometimes usage rules. It reasons over that interface when deciding what to call. So a bad tool description can break the system in the same way a bad prompt can. If a tool is named vaguely, the model may call it at the wrong time. If the argument schema is too loose, it may pass ambiguous inputs. If dangerous side effects are not clearly separated from safe read-only operations, the runtime becomes harder to secure. Good tool design is boring but important. Clear names, narrow responsibilities, typed arguments, examples, explicit permissions, and predictable errors. For AI coding, this is why tools like read file, search files, patch, terminal, and git status should be separate capabilities, instead of one giant do-anything function. The model needs affordances it can understand. Now add MCP, the Model Context Protocol. Anthropic introduced MCP as an open standard for connecting AI assistants to the systems where data lives: content repositories, business tools, databases, development environments, and local applications. The reason it matters is that before a standard protocol, every AI app needed its own custom integration layer. One assistant might have a GitHub plugin, another might have a Postgres connector, a third might have a file system tool. Each one used different conventions, different configuration, and different permissions. MCP tries to standardize that connector layer. An MCP server exposes capabilities. An MCP client, which is usually the assistant or agent host, connects to that server and discovers what it can do. Those capabilities can include tools, resources, and prompts. So MCP is not magic agent intelligence. It is not the model. It is not the planner. It is not the thing that decides whether the task is complete. It is the standardized pipe between AI applications and external capabilities. The easiest analogy is, tool use is the act of plugging in and sending a command. MCP is the connector standard. The agent is the system deciding which connector to use, when, and why. An agent is the next layer up. An agent is not just a model with tools. It is a model inside a loop. The loop looks something like this. Understand the goal, inspect the current context, make a plan, choose an action, call a tool, observe the result, update state, decide the next action, and eventually verify whether the task is done. This is why react reasoning plus acting became such an important pattern. The model is not just answering from memory. It can reason, act, observe, and continue. A coding agent is the easiest example. The user says, "Fix the failing login test." The agent does not know the answer immediately. It searches the repo, reads the test, runs it, sees the error, opens the implementation, makes a patch, runs the test again. Maybe the first fix fails. It reads the new traceback, updates the patch, and verifies the result. That is agentic because the path is not fully predefined. The model is dynamically directing the process based on observations. A workflow can use a model too. But in a workflow, the steps are mostly fixed. In an agent, the model helps decide the steps. Here is the practical decision tree. If you need one predictable external operation, use tool calling. The user asks for a database lookup, a calculation, a calendar conflict check, or a weather query. The system can call one tool, validate the result, and answer. No need to invent an autonomous agent. If you need a portable integration across different AI apps, use MCP. You have a local file server, a company database, a browser automation server, or a GitHub integration, and you want multiple assistants to access it through the same protocol. MCP solves the connector problem. If you need a fixed multi-step process, use a workflow. For example, classify the email, extract fields, create a ticket, notify Slack, and log the result. The model may make bounded decisions, but the control flow is predetermined. If you need adaptive multi-step problem solving, use an agent. Debugging unknown errors, researching a topic across sources, refactoring code, investigating logs, or operating a browser toward a goal, these tasks require the system to inspect results and choose the next move. The mistake is using the most powerful pattern everywhere. Agents are flexible, but flexibility costs money, latency, testability, and safety. If a deterministic workflow works, it is usually better engineering. So where does MCP fit in an actual agent? Think of the agent runtime as the orchestrator. It owns the loop, state, policies, approvals, traces, and stopping conditions. MCP servers provide some of the capabilities available inside that loop. A coding agent might connect to a file system MCP server, a GitHub MCP server, a browser MCP server, and a Postgres MCP server. The agent decides when to call them. MCP standardizes how those calls are discovered and routed. But MCP does not remove the hard parts of agent design. You still need to decide which tools are exposed for a task. You still need permission boundaries. You still need to handle bad outputs. You still need to prevent prompt injection from a web page or issue comment from turning into an unsafe tool call. MCP makes capabilities easier to plug in. It does not make them automatically safe. A lot of agent failures come from blurring these layers. Failure mode 1, calling a single tool call an agent. This leads people to overestimate what the system can handle. It can answer a structured request, but it cannot manage a long-running task. Failure mode 2, treating MCP as agent intelligence. MCP can expose a database tool, but it will not decide whether querying that table is relevant, whether the result is stale, or whether the answer satisfies the user. Failure mode 3, over-agentifying automation. A deterministic script with 5 clear steps may be more reliable than an LLM deciding those steps every time. Failure Mode 4. Exposing too many tools. The model sees a giant menu of capabilities, many irrelevant, some dangerous, and the probability of bad selection goes up. Failure Mode 5. No observability. If you cannot see which tools were available, which call was chosen, what arguments were passed, and what came back, you cannot debug the system. And Failure Mode 6. Unsafe side effects. Reading a file is not the same as deleting a file. Drafting an email is not the same as sending it. Searching the web is not the same as posting publicly. The more agentic the system becomes, the more you need guardrails. Here is the clean mental model. Tool use is a capability. MCP is a protocol for exposing capabilities. A workflow is a predetermined control path that may include model calls and tools. An agent is an adaptive control loop that uses a model to decide what to do next. Those layers can be combined. A production agent may use tool calling through MCP inside a larger workflow with human approval gates. That is normal. But naming the layers correctly matters because each one has different engineering questions. For tool use, ask, is the schema clear, safe, and reliable? For MCP, ask, is the integration portable, permissioned, and observable? For workflows, ask, are the steps deterministic and testable? For agents, ask, can the system recover from surprises, evaluate progress, and stop safely? The future is not everything becomes an agent. The future is layered AI systems, simple tool calls where possible, workflows where reliable, MCP where interoperability matters, and agents where adaptation is worth the risk.